Atoms, elements, and the periodic table. Atoms are made up of protons with a positive charge, electrons with a negative charge, and neutrons no charge. Atoms are uniquely described by the amount of protons in their nucleus. For example, an oxygen atom always has 8 protons. A calcium atom always has 20 protons. Atomic number is the number of protons in an atom. Elements are substances that are made up of only one kind of atom. The words element and atom are often used interchangeably due to their close relationship. Elements are pure substances made up of only one type of atom. So we have gold over here, carbon in your pencil, silver, and then neon gas. The periodic table of elements contains physical and chemical information about every element that matter can be made of in the universe. The pillars of creation, part of the Eagle Nebula shown to the right, is a cloud of interstellar gases 7,000 light-years from Earth, made up of the same gaseous elements found on the periodic table. Why is one of the most useful tools ever created by humans called the periodic table? When scientists were organizing the known elements, they noticed that certain patterns of chemical and physical behavior kept repeating themselves. For example, over here, lithium, sodium, potassium. These elements are all shiny metals and react violently in water. On the right side, we have these elements are all very stable gases: helium, neon, argon, krypton, xenon, and radon. These patterns were so predictable that Dmitri Mendeleev was actually able to predict the existence of elements 31, remember that's 31 protons, and germanium, and their approximate masses before they were discovered based on the existing patterns of known elements. Mendeleev's work preceded the discovery of subatomic particles like protons, neutrons, and electrons. Here's a copy of Mendeleev's first periodic table from 1869, and hopefully you can see that there's some things missing here. Mendeleev proposed that elemental properties are periodic functions of their atomic weights. An atomic weight is equal to the mass of the protons and the neutrons combined, and he ordered the elements by weight. This ordering failed for a few elements, but Henry Moseley fixed the problem by ordering the table by atomic number, which of course is the number of protons. Element properties are periodic functions of their atomic number. Atoms are listed on the periodic table in rows based on their number of protons. And if you'd like to back up a slide, you'll see how Mendeleev organized it by atomic weight. The periodic table is made of rows and columns. The rows are called periods, and the columns are called groups. Groups are sometimes referred to as families, but groups are more commonly used. Here's the current periodic table. We have the elements organized in terms of groups, which go down, and periods, which go across. So if you'd like, please pause this for a second and just look at all the different elements we have. Here's a version of the periodic table with just the symbol and the atomic number for each element. So let's see, here we have our groups from left to right. Here are the periods. And let's look at this one over here. The first element is hydrogen, and its atomic number is 1. It has 1 proton. Over here, we have oxygen. Its atomic number is 8. It has 8 protons. Here are the names of the first 20 elements, along with their symbol and atomic number, which is the number of protons in their nucleus. So let's just look here at beryllium, and we have the symbol because it's easier to write than just spelling out beryllium every time. And here would be beryllium, atomic number 4. Chlorine, atomic number 17, and where's that? That's right over here. Another version of the periodic table. This time we don't have atomic numbers, but we have different colors for the elements. The families, which go from up to down, have similar chemical properties and have special names. We're going to go over those in the next few slides. But over here on the left, we have alkali metals. Over here on the right, we have noble gases. And here's a little song with all the elements in it. This unit will not deal with the transition elements in blue and green. That's over here. Right there's blue, and here's green. Because of that, we're going to renumber the remaining groups, which are called the main group, are renumbered from 1 through 8, and we'll be using that going forward. 3 important groups are 1, 7, and 8. Group 1 are the alkali metals. They are very reactive and soft. Group 7 is called the halogens, also very reactive, and they are nonmetals. And finally, group 8, the noble gases, are nearly inert and rarely react. And just to emphasize again, the main group numbers 1 through 8 will be used for the rest of this unit.